Hello everyone, welcome back for another lesson. So today we're going to talk about dilution. So this is going to be a quick one on the concept of dilution. So we know that when we dilute something, we add a solvent, normally it's water, to our mixture to change its concentration. So in this example, we're looking at Minute Maid orange juice. You're probably familiar with this type of juice. It comes in a frozen form. It's in a cardboard box, and you add cans of water to the mixture. Now, if you follow the recipe, some people, such as myself, might find that it's too bland. It's not sweet enough. So sometimes we put less, or sometimes if somebody, let's say, would find that it's too sweet, they might decide to add more water. So we're playing around with the concentration. Now, how do we determine the new concentration based on the amount of solvent added? That's what the dilution formula can help us with. So the formula says concentration 1 times volume 1 is equal to concentration 2 times volume 2. So it could be also seen as concentration and volume 1 are the initial format or the initial quantities, and these would be the final quantities. So looking at the problem, it says your McCain orange juice is too sweet, so you decide to add some water to it. If you had 250 ml of juice with a concentration of 5 grams per liter and you add another 50 ml of water to it, what will be the final concentration of your juice? So before we start solving, I want to point out that this equation is wonderful in the sense that it works with any unit of concentration or volume. You could work with a percentage, with a concentration in ppm, with a concentration in grams per liter, mole per liter, it does not matter. As long as your two concentrations have the same unit and your volumes have corresponding units. So these could be both in milliliters or in liters, and they don't even have to match the concentration unit. So in other words, your concentration could be in grams per liter, but your volume could be in milliliters, as per our example here. So I'm going to demonstrate to you how this actually works. So let me just take my pen and let's start listing our information as usual. So it says that we have originally a volume, so volume 1 of 250 milliliters and a concentration of 5 grams per liter. So I will not convert my volume. I do not need to. I'm going to show you why in a moment. I'm going to just list the rest of my information. So V2, it says that you're adding. So you have to be careful about that when you read the problem. This is not my final volume. I'm adding water to my initial volume. So 250 plus another 50 gives me 300 ml, right? Because I had 50 plus 250. And I'm looking for my final concentration. So C1, which is 5 grams per liter, times its volume of 250 milliliters is equal to concentration number 2 times volume number 2, which is 300 ml. So if I look at my units, my ml, let me take another color. So my milliliters would cancel out, and I would be left with grams per liter for my second concentration. So that's why we don't need to convert necessarily the units when we use this equation C1V1, C2V2, because our units are going to cancel out. So as long as your two volume units are the same and or your two concentration units correspond to one another, so are the same, then you're fine. Okay, so back to the problem. This gives me a concentration 2 of 4.1666 gram per liter. Now, if I do the significant figures, this has 3 sig figs, 2 sig figs, and 3 sig figs. So, oh, they all have 3, sorry. So I need to keep 1, 2, 3 sig figs. I'm cutting here. The first digit that I drop is a 6, which means I'm going to have to turn this into a 7. So my final answer is 4.17 grams per liter for the new concentration. So we went from 5 grams per liter down to 4.17 grams per liter by adding 50 ml of water to our juice mixture. So that's it for dilution, sorry. If you have questions, you can write them in the comment section below, and otherwise I will see you for your next lesson. Until then, take care.